Okay, let's give you guys some more practice. So find an arc length parametrization of t squared t to the power of 3. So let's just imagine after 2 seconds the particle travels this amount of a distance. Let's say it has covered, let's say 9 meters. Imagine this length is 9. So what this means is me asking you to somehow create a machine in such a way that if I feed you the distance, you should be able to give me the location or the vector to that point. So how far across, how high up, basically fill in the blanks. Where I feed you the length, you got to tell me the location. So if I told you that oh, I have traveled 20 meters along that line, where will I be? Find the location. So 20 meters, where would that be? Somewhere around here. So so where will this location be? So that's just like me asking you this. It's like me asking you where I will be after I've traveled, let's say 20 meters. Well, anyway, fill in the blanks. So press pause and have a go. Okay, so to do this, we know that the formula of the arc length is given by this, but we no longer use this because it's just too complicated. We would just use this. So our first task is to find this thing here. Later on we can integrate it, and then we can seek this. We can try and find this later on. So our first step is to find this. So starting out with this, we need to differentiate it to get r prime. So differentiate this, that will then give you this. Differentiate this, that will then give you this. Now to find the modulus, to find the magnitude, we would use Pythagoras. So square this, that will then give you this. Square this, that will then give you this, and then take the square root of the whole thing. That will then give you the magnitude. So once you've got the magnitude, hang on. So once you've got the magnitude, we can now find this, integrate it from 0 to t. So once you've got the magnitude, integrate it from 0 to t. So that will then take us to here. We need to integrate it with respect to u. So so tidy this whole thing up. We can rewrite this as one block multiplying another block. This will simplify to u, and this thing stays the same. Now this should be easy to integrate because you can see that this is the exact derivative, well, near enough the exact derivative of this thing here. So you know it's easy to integrate. So don't bother using substitution. Because you know this is easy to integrate, let's make this to be our initial guess. Currently we're at a half. So when you integrate it, it's going to be one notch higher. So it's going to be 3 over 2. So make this to be your initial guess. Hang on. So basically we're trying to integrate this here. So if you make this to be your initial guess, if you differentiate this, that will then give you 3 over 2. The bubble stays intact. The power gets minused by 1. 1 over 2, but then you've got to times the derivative of the bubble itself, which will be 18u. So notice that this u here matches up with this. This thing here matches up with this. We just need to negate this. So going back to your initial guess, negate it. That would be 2 over 3, but then we've got to negate this as well. Blah, blah, blah. Do whatever you want. You can use substitution if you want to, but because you know this is easy to integrate, then, well, if you integrate this whole thing, it will give you this thing here. Okay, so now we can put this, hang on, let me think. Yeah, so now we can factor this out. If you put this into here and then take away, put this into here, that will then give you this thing here. So so tidy this up, that will then give you this. So S of t is given by this. So what that means is you give me a time and I can tell you how far you have traveled along this path. So that's what this thing here means. So if you give me a 2, then all I need to do is put 2 into this t here, and then it will tell me this arc length here, this length here. But our ultimate aim is to create a machine in such a way that if I give you a length, let's say 8 meters, you can tell me the location. This is our ultimate aim. You give me a length, and then I will give you the location. So this is our ultimate aim here. So going back to this, if we know the length, if we know the length along this path, we can work backwards to find out the time. So our next step is to find the time, and once we've got the time, then we can stick it into this thing here, t squared t to the power 3. So from here, if you know the length, you can work backwards to find the time. So let's do that. So if we know the length, if we know the length, we can work backwards to find out the time. So rearrange, blah blah blah, rearrange it to make t the subject. That will then give you this thing here. So if we know the length, we can work out the time. The time will be given by this in terms of the length. So t is given by this. Now once we know t, we'll tidy this thing up. That will then give you this. Once we know t, we can put it back into here and into here. That will then give us the location in terms of s. So in terms of s, the location would be, well, put this into here, put this into here. That will then give us this thing here. So this is our final answer. Okay.